AP Precalculus 2025 free response question number 4. Here again we are not allowed to use calculator. The functions g and h are given by g of x is 2 logarithm 3 base x and h of x is 4 cosine squared of x. Part I is asking g of x is equal to 4 for values of x in the domain of g. So we're going to set g function equal to 4 and solve for x. So g of x is equal to 2 logarithm 3 base x and then set it equal to 4. Here we're going to utilize the properties of logarithm. So if you have a logarithm base b argument c, then you can bring this as a power of the argument. So it's logarithm b base c to the a. So we're going to utilize this rule. So logarithm 3 base x squared is equal to 4. Now we're going to convert this log function to exponential function. If you have log base b to the c equal to, let's say, a, then it's going to be b to the a is equal to c. So base does not change, input and output switch, because exponential and logarithmic functions are inverse functions. So here we're going to do the same. 3 to the 4th is equal to x squared. From here 3 to the 4th is 81 is equal to x squared. From here x is equal to plus or minus 9. We're going to reject the negative part because argument cannot be negative here. So x value is equal to 9. So that's AI. AII part is asking for 4 cosine squared of x is equal to 3. In the domain of 0 to pi over 2. Be careful about the domain here. So we're going to divide both sides on 4. So cosine squared of x is equal to 3 over 4. And then square root on both sides. So cosine x is equal to plus or minus radical 3 over 4, which is plus or minus radical 3 over 2. Square root of 4 is 2. And on the unit circle that you need to know, there are 4 values of cosine x here. But our domain is between 0 to pi over 2, so it's going to be on the 4th quadrant. On the 4th quadrant, this point, cosine is equal to radical 3 over 2 at pi over 6, which is 30 degree. So x value is equal to pi over 6 only. Other values 5 pi over 6, 7 pi over 6 and 11 pi over 6 is not in the domain. So this is the only answer. Part B. The functions j and k are given by below here. Rewrite j of x as a single logarithm base 2 without negative exponent. Alright, let's work on this. So we have log 2 base x plus 3 logarithm 2 base 2. So again, utilizing this property here, we can bring the coefficient as the power of the argument. So log 2 base x plus logarithm 2 base 2 to the 3rd. And 2 to the 3rd is 8. Let's simplify it. Logarithm 2 base x plus logarithm 2 base 8. Now we can compact addition as multiplication. So logarithm 2 base 8x. This is our final answer. We utilize this rule. Logarithm b base xy is equal to logarithm b base x plus logarithm b base y. If you have, this is the product rule. If the argument is in the product form, you can expand as addition on the same base, or compact similarly. So that was BI part. BII part is asking, rewrite the k of x as an expression in which tangent x appears exactly once and no other trigonometric functions are involved. Okay, so here we are given 6 over tangent x cosine squared x minus 1. Cosine squared x minus 1 using the Pythagorean identity is equal to cotangent squared of x. Because by Pythagorean, cosecant squared of x minus 1 is equal to cotangent squared of x. From here, we know that cotangent is the reciprocal function of tangent. So I can rewrite this as tangent squared of x, 1 over tangent squared of x. So 6 over tangent x multiplied by 1 over tangent squared of x. One factor of tangent cancels tangent x there. So 6 over 1 over tangent x. 6 over 1 over tangent x is equal to 6 tangent x. Just keep change flip the fraction. So 6 tangent x is the answer on this part. Alright, let's go to the last part. In the last part of the problem, we are given m of x as e to the 2x minus e to the x minus 12. Find all input values in the domain of m that yield to an output value of equal to 0. So we're going to set this function equal to 0 and solve for x. E to the 2x minus e to the x minus 12 equal to 0. Here, let's call e to the x some variable. Let's call e to the x as w. So it's going to be e to the 2x, then will be w squared. Because e to the 2x is e to the x to the second. You can switch the powers here. So it's going to be w squared. So now let's rewrite this function. It's going to be w squared minus w minus 12 equal to 0. Now it's a quadratic function. So two numbers that multiply negative 12 and add up to negative 1. It's going to be negative 4, positive 3. And from here w is equal to 4 and w is equal to negative 3. But we're solving for x, not w. So let's put w back. So we said that e to the x is equal to w. One value of w is 4. So from here, ln on both sides. We know that ln of e is equal to 1. Same base, same argument. So here x is equal to ln of 4. Another value of w was negative 3. So e to the x is equal to negative 3. ln on both sides. So x is equal to ln of negative 3. But we're going to reject this answer because argument cannot be negative, because domain of the ln is starting from 0 to infinity. So the answer is x is equal to ln of 4. Thank you for watching. I hope it helped.